Welcome to part 2 of the Hyperbolic Trig identity tutorial. We're going to be going over the double variable formulas and compound variable formulas. Starting off with the compound variable formulas. So we have the definitions of the hyperbolic trig functions. Just as a reminder, we're only going to be going over the few, and you'll see why in a bit. So starting off, compound variable formulas. So I'm going to just do some preliminary work here by multiplying sinh x and cosh x. Sinh x and cosh y. So we have the definition of sinh x times the definition of cosh y, and that is equal to this mess of things right here. If you do all the expansion, then you're multiplying e to the x, e to the y, e to the x, e to the negative y, e to the negative x, e to the y, and e to the negative x, e to the negative y. With that, plus signs, minus signs, that, you get this. So e to the x plus y plus e to the x minus y minus e to the y minus x minus e to the negative x minus y. Okay. Now that we're done that, we can look at the opposite of this. What we're going to do is multiply cosh of x and sinh of y. Now all this is doing is just switching the variables around, because here this is equal to cosh of y, sinh of x, if you just change x to y and y to x. So this is equal to e to the y plus x, and etc., which we're just going to rewrite as e to the x plus y minus e to the x minus y plus e to the y minus x minus e to the negative x minus y. And this is just going to make the algebra a little bit easier to notice. Now we're going to multiply each type of hyperbolic trig function with the with two different variables. So I'm throwing in cosh of x times cosh of y. This is the definition of the multiplication. And what I'm doing here is just it's the same algebra as what we've done here, but you're switching around the plus and minus signs. So all of these now are plus signs instead of the occasional minus sign in this one. And finally, we multiply sinh of x times sinh of y. You get the definitions from above, and you have that e to the x plus y minus e to the x minus y minus e to the y minus x plus e to the negative x minus y. Okay, so why have I done all of this? Because when you multiply these together, you get something that looks like the hyperbolic trig function of x plus y. But the problem is you have these other terms here, like e to the x minus y and e to the y minus x. And what I intend to do is get rid of them. So that's exactly what I'm going to do. Starting off with the first couple of things that we've defined. That is, we are going to add sinh of x times cosh of y and cosh of x times sinh of y. So that is equal to two times e to the x plus y minus 2 times e to the negative x minus y. As you can see here, we have minus e to the x minus y and plus y e to the y minus x for the cosh x times sinh y, and that cancels out with the two terms over here. So you can factor out the 2, and that gives you e to the x plus y minus e to the negative x plus y over 2. And this is exactly the definition of sinh of x plus y. Furthermore, you take cosh of x times cosh of y plus sinh of x times sinh of y, you get 2 times e to the x plus y plus 2 times e to the negative x minus y over 4. As you can see, these two terms cancel out here. And you can factor out the 2. You get e to the x plus y plus e to the negative x plus y. And that is exactly the definition of cosh x plus y. Now that we have those, it's going to be a lot easier to do the double variable formulas. Starting off, we have sinh of 2x equals sinh of x plus times cosh of x plus cosh of x times sinh of x. So that's just 2 times sinh of x times cosh of x. This is starting to look a little bit more similar to the double angle formulas for non-hyperbolic trig functions. And in fact, a lot of these are very similar. The only difference is you're adding these two instead of subtracting them, which what you would do for the regular trig functions. Anyway, cosh of 2x equals cosh of x times cosh of x plus sinh of x times sinh of x, which is cosh squared x plus sinh squared x. Okay, now the last thing we are going to do here is do a double angle formula for tanh of x, because I had defined this here, but I haven't used it yet. Now, this one has a very elegant solution. I'm going to start with doing the reciprocal of tanh 2x, because it's just going to make the algebra a little bit easier. This is equal to sinh squared x plus cosh squared x divided by 2 sinh x cosh x, because this is because 1 over tanh 2x is sinh 2x, it's cosh 2x divided by sinh 2x. And these are the formulae for cosh 2x and sinh 2x. This is equal to, we're simply splitting up the fraction here into sinh squared x and cosh squared x, which is equal to, we factor out the 1 over 2, sinh x over cosh x plus cosh x over sinh x. And this is all tanh x plus the reciprocal of tanh x. Remember, we still have the 1 over 2 factored, but we're going to bring it back in, because with some fraction algebra, we get tanh squared x plus 1 divided by 2 tanh x. Therefore, tanh 2x equals 2 tanh x divided by tanh squared x plus 1. This is it. These are the compound angle formulas, compound variable formulas, and double variable formulas for the hyperbolic trig functions. Hope you all enjoyed watching this video. Stay tuned for the next one. And you can factor out the 2 out of the denominator to get e to the x plus y plus e to the negative, in brackets, x plus y over 2. And that is equal to cosh of x plus y. Okay. I beg your pardon.